All right, so these notes are on finding intercepts using technology. So what you're going to notice with today's notes is that they're going to seem very familiar due to the fact that they are the problems from previous notes. We're just using a calculator to find the X-intercepts, Y-intercepts, and zeros instead of doing it algebraically. All right, so let's get started with warm-up. No calculator required for the warm-up. Go ahead and pause the video, try to find the domain and range for each function. All right, let's see how you did. Looking at this first one right here, the domain. Farthest left it goes. It looks like it starts there, or the graph starts there. There is no arrow pointing to the left, so that is where my graph starts, which is -5. There is a value there. It is a closed point, so I'm going to be using a bracket, comma. All right, so now if I look as far as it goes to the right, I could say, oh, it goes to infinity, but I do notice that there is a hole in the graph here and there's no values at -2. So I'm going to break this up into chunks here. So there's x values here, and then all of a sudden there's no x values at -2. So you should say it stops at -2. There's no x values at -2. It picks back up at -2, and then it goes on forever to the right, which is infinitely. My range, let me erase my highlighter here. My range, the lowest my graph goes, -4 it looks like. There's no arrow pointing down, so that is the lowest my graph goes. Notice that there is no point there. That's what that open circle means. So I'm going to say a parentheses to not include the value of -4. And then here's what I was talking about on the warm-up, or yesterday's notes, the domain and range notes. Some people will accidentally say the y values go to 4 because they look with the highest it goes and just look right to that level. But the highest y value is not 4. Why? Because this arrow indicates that the graph goes on forever and ever. So really, if you notice, if I were to extend it, it would go past 4. So it goes on forever and ever. So that would be infinitely. Moving on to the next one. Same idea, farthest left it goes, -6, or sorry, people will say -6, but that's an arrow. So it's -infinity. I don't like that right there. Comma, no gaps, no holes, no jumps, no asymptotes. Stops right here, which is at 7. There's no arrow pointing to the right, so it does stop at 7. And there is a value at 7, so bracket. All right, now we're going to do the y values, the range. The lowest it goes looks right here. Now you might be saying to yourself, oh, that's like negative point something. We tried our best to get the graph to go a little bit lower. In fact, I might fix it for class, who knows. So it's supposed to be at -1, and it's supposed to actually touch there. So I apologize that you can zoom in. When we weren't able to zoom in, it was paper, no one ever noticed. There are values there, and if you're like, no, they're not, let me fix the graph, and then I'll actually fix the notes so that it's supposed to look like this. There we go. Here we go. Now there is values at -1. And then the highest it goes. Once again, if you look and you're just like, oh, the highest it goes is right here. I have to move this down. Notice it looks a little higher, so I'm going to fix it for you guys for class. So you might have not even noticed on yours because it should be fixed. The highest it goes is 4. But then you say, wait a minute, is there an arrow pointing up? There is, so the highest it goes is not 4. It goes on infinitely forever. All right. All right, next one, farthest left it goes, that's an arrow pointing to the left, -infinity. Notice there's an asymptote right in the middle of the graph. Okay, not the graph paper, but in the middle of the graph. There's no values there. So I'm going to say there's no values at -2. But then there's no piece that picks up, but there's still no values at -2, and it goes on forever. The range, the lowest it goes, arrow pointing downward, so -infinity. And then the highest it goes, arrow, this is continually going up. You might be saying it's leveling off, but that would be if it was pointing directly to the right horizontally. It's not, so it's continually going up, so it goes on infinitely. And there is that part of the warm-up. All right, now we have the second part of our warm-up. It's a word problem. It says A to Z toy boat company found the average price of its boats over a 6-month period. The average price for each boat can be represented by the polynomial function, and then it gives us a function p of x, where x, the input, is the month, and x is in between 0 and 6, not including 0. Use the graph to estimate the average price of a boat in the 4th month Confirm your estimate algebraically with your calculator. Okay, so let's use the graph first. So we'll do a estimate first using the graph paper. And then we will do it algebraically. So the 4th month. So we want to find P of 4. And we're going to use the graph first. So here's the X value of 4. So if I look up, it looks to hit right about there. So I want to guess what that Y value is. It's something in between 24 and 7, which is closer to 25. So I'm going to guess the Y value of 25. I'm going to guess this is the point 4, 25. Guess. Okay. All right, so my guess is 25. Meaning my guess is 25. The output is in dollars, right? The average price, yes. So my average price, or my guess is $25. All right, so now let's algebraically see what it actually is. All right, so we're going to find P of 4 algebraically. So we're going to do negative 0.325 times 4 cubed plus 1.5, 4 squared, plus 22. Notice it says with your calculator. So we do get to type this in our calculator. I'm going to pull up my calculator, hopefully. Let's see. Yes, split screen with it. I'm going to move it over a little bit just so there's a little bit more room for notes. I'm going to keep it open because these next 4 are also algebraically. All right, so let's go ahead and type that in. So we're going to do negative 0.325, open a parentheses, 4, close a parentheses, square it. Sorry, that was a cube. So let me change that to a cube. Plus 1.5, open a parentheses, 4, close it, square it, plus 22. Enter. 22. Enter. 25.2. So, algebraically, we get $25.20. Now you might feel the need to be like, I'm going to change my estimate. Don't. Your estimate was a good estimate, or my estimate, I should say, was a good estimate. $25 is really close to $25.20. A bad estimate would be $27 or $2. Those are bad estimates. Okay, so next example 4, use your graphing calculator to find the X-intercepts, Y-intercepts, and any zeros of each function. So notice this looks very similar. Well, not very similar. It's the same exact problems from the prior notes where we had to do this algebraically. Difference is I didn't give you room because you don't need room. Your calculator is going to do it for you. And that's the only difference. All right, so let's go ahead and start with A. All right, so we're doing this graphically. What we're going to do is we're going to look at the graph, and we're going to see what the Y-intercept is, what the X-intercepts are, or the zeros are. We just know zeros are written as X equals, X-intercepts are points. All right, so we're going to hit Y equals to get to our, where we enter our equations so that we can graph. So it already has the Y equals for us. We're typing X cubed, so X to the, that caret right there that just lit up, 3rd power. My calculator makes me hit it to the right so I can get out of the exponent, minus X. All right, so now I want to make sure everyone's calculator is set up correctly. So I could just hit, I know mine is right now, and I can just hit graph and then I'll see it, okay? But what we're going to do is we're going to reset our calculator, our graphing screen. So it's always on graph paper that goes the X values of -10 to +10, Y values of -10 to +10. And then if we have to adjust, we can, okay? All right, so we're going to hit zoom. Option number 6 is standard. That will set it to the -10 to 10, -10 to 10. You can just hit 6 or you can toggle down to it. All right. So we can see that we get this cubic function here, and we want to find the Y-intercept and X-intercepts, okay? The Y-intercept is very easy to find, okay? To find the Y-intercept, you're going to hit trace. And it actually found it for us already, but we're going to actually hit 0 because it's going to plug in the X value of 0, and it's going to show us what the Y value is once we hit enter. So it tells us that the Y value is 0, so our X-intercept is 0. Sorry, our Y-intercept is 0, 0. Now our X-intercepts, we're actually going to find our zeros, and then we'll write them as X-intercepts. So the way my graph looks right now, I'm going to be honest with you, it's hard for me to tell how many there are. Is it just 0, 0, or are there multiple ones? And I don't remember from yesterday's notes. So I can go like this and look, and it doesn't help me anymore. So what you can do is that you can hit the zoom button. Option number 2 is in, and then hit enter, and it'll zoom in like, oh my goodness, I can see that so much better, right? All right, now you might be looking at it and be like, I can tell what the zeros are. Great, but sometimes they're not perfect looking. So let me show you how to do that using your graphing calculator. So what you're gonna do is you're gonna hit this trace button here, but before you hit trace, we're gonna hit the second button, this blue button right here, and then hit trace, which is actually gonna go into calculation. So if you look, it says calculate up top. Option number 2 is 0. And now if you look at the bottom of the calculator screen, it's asking us for a left bound. So if you look, I have the x-axis 3 times. I need to find all 3 of those. So let's start with the one the farthest to the left. I'm gonna use this toggling right here. You guys are lucky you can just hold down on that button. I have to keep clicking it because it's on the computer. All right, so I'm to the left of that first 0. I'm gonna hit enter. Now I wanna toggle to I'm to the right of that 0, and I'm gonna hit enter. And now if you look at the bottom, it says, do you wanna guess? I'm gonna hit enter one more time. And it tells me that that point is -1, 0. So I have an x-intercept of -1, 0. And my first 0 on the screen is x equals -1. All right, now I'm gonna find the one in the middle. So I know it's 0, 0, but just to show you, second trace, option number 2 is zeros. I'm gonna get to the left of that one that looks like it's at 0, 0. Okay, I'm close enough to it. I'm gonna hit enter. Now I wanna be to the right of it, so I'm gonna keep toggling until I'm to the right of it. I'm gonna hit enter, and then it says guess, hit enter, and it tells me that one's at 0, 0. So my x-intercept is also 0, 0. And that means there's a 0 at x equals 0. The very last one, I know it's 1, 0, but just to show you once again, second trace, 0. Toggle to the right until you're to the left of that 0, hit enter. Now until I'm to the right of it. There, I'm to the right of that 0, hit enter. Sure enough, it's 1, 0. So my third y-intercept is 1, 0, x equals 1. So if you recall back to yesterday's notes, or sorry, the previous day's notes, it was actually faster to do it algebraically. All right. I think all of these are because your skills build so much, okay? But we can do them graphically. All right, let's go ahead and move on to the next one. We're gonna go y equals. I have to hit clear. I wanna hit clear. I don't wanna type over things. It gets messy if I type over things. All right, I'm gonna do square root, second x squared right there. It's in blue if you don't see it. All right, x plus 4. So I forgot to show you where the x was in case you didn't know. I would explain it in class, obviously, in case no one knew where it was. But if you look to the right of this alpha green key, there is a button that says x, comma, t, comma, theta, comma, n. Those are a bunch of variables. So it's any variable that you would use in a standard equation here. So since we're using functions, it's going to give me x when I hit that. Now I need plus 4. All right, now I need a -5, but I don't want to be underneath the square root. So on my calculator, I toggle to the right. If your calculator opened a parentheses before your x, this is where you would close it. I'm going to toggle to the right, -5. All right, if I hit graph right now, it's going to open up on the same exact paper. So I'll do that right now. It's going to open up the same exact screen that I just had. So if I hit graph, notice it's that same screen, and I see a little smidge in the bottom right-hand corner, right? That's why I don't see the graph, is because it's zoomed in. So I'm going to try to reset it by hitting zoom standard, zoom 6, to that -10 to 10. And I say, ooh, okay, that's what it looks like. This is a square root function. All right, so I want to know the y-intercept. If I look on my screen right now, I can physically see the y-intercept. So I'm going to use my calculator to find it. I'm not going to guess where it is. I'm going to hit trace. And I want to know when x is 0, what is y? 0, -3. Now I want to find the x-intercept. I physically cannot see the x-intercept on my screen right now. I can't see it. That means my calculator will not find it if it's not on my screen. So I know that it's to the right, because if you notice, it's going up a little bit more and more and more. I know it's to the right, but I don't know how far it is to the right. So I need to adjust the screen, which is called the window. So now I'm going to hit the window button, which is located right next to y equals. It's on that top group of 5 right there. It's the second one. Hit window. So right now my X values are going to 10. I need to make it something bigger than that, okay? So let's say I'm going to do trial and error, and I'm going to try 20. And I'm going to hit graph. Come on, X-Intercept. Oh, so close, right? It might be hitting it. I don't know, but I can't tell for sure. So I'm going to make it even bigger. So I'm going to go window. I'm going to make it 30. Graph. There we go. It hit at some point. Can I tell? No. I really can't guess this. But I know it's a 0. So I'm going to hit second, trace, which is calculate. Option number 2 is 0. I want to be to the left of the X to that 0. I'm definitely to the left already, but I'm just going to get a little bit closer. Okay, there. And now I want to be to the right. So I don't know exactly where it hits. So I'm just going to keep moving it to the right until I know for sure it's above the y-axis. Like right now it's above the y-axis because that means it had to have crossed the y-axis. If you're not sure if you're above, I'm looking at the y value right there, but now I can see it's definitely above. So I'm going to hit enter. Should I guess? Yes. And it tells me that it's 21-0. And if you have a good memory recall, that was what the 0 was, and that's what the X-intercept was. All right, next one. We're going to go to y equals. We're going to hit clear that out. 3x to the third power, so x is right next to alpha again. Caret, third power, get out of your exponent. Minus 10x squared. Minus 8x. I'm not going to hit the graph button because once again, it's that what I just changed it to. So I'm going to hit zoom standard to set it back to normal. And I can see the X-intercepts. I can see the Y-intercept, right? Like I can't tell what they are, but I can see them. And if you want to zoom in, you can. I might accidentally not see that one to the far right if I do. So let's zoom in. 2, enter. And I'm going to miss that. So there's 1. And then I'm missing the one that comes back out. So I'm going to zoom back out. Zoom out. Zoom out. 3, enter. All right, so though it's not the most clear picture in the world, at least I can see that there's 1, 2, 3 X-intercepts and 1 Y-intercept. And I could already tell at the bottom of my screen that my Y-intercept 0, 0. But just again, once again, because you can find any Y value, or sorry, any X, given any X value, you can find any Y value. So I'm going to hit trace, and I'm going to plug in whatever X value I want. So if I wanted to plug in 27 to this equation, I can plug in 27 right now, and it'll tell me what it is. I'm going to plug in 0, hit enter, and it's 0, 0. What I mean by that is, like, if I wanted to plug in 1 right now, like if I want to know what 3 times 1 cubed minus 10 times 1 squared minus 8 is, I can hit trace, hit 1, hit enter, and it'll tell me that you get negative 15. Isn't that nice? All right, but I don't want to know that. So I want to know the zeros now. So I'm going to hit second trace, second calculate. Option number 2 is zeros. I'm going to go for that 1 on the far left. So I'm going to start moving my cursor. All right, I'm to the left of that first 0. I'm going to hit enter. Now I'm going to move it to the right, and it is above the y-axis. Now I can tell by the y value. But if I want to move it a little bit more, I can. Hit enter, and then one more time. So it says it's negative 0.6 repeating. I will accept that since this is a calculator problem as an answer, or you can round to 3 decimals, or you can convert it to a fraction, which is negative 2/3. I'm okay with that. So my first one, negative 2/3 or negative 0.6, I'm going to do negative 0.667. I'm going to round to 3 decimals. In pre-calculus, when no directions are given and you have a decimal that needs to be rounded because you don't know how to convert it to a fraction, 3 decimal places. That means I have x equals negative 0.667. Yesterday we got x equals negative 2/3. All right, my second 0 is 0, 0, and I can tell by the X-intercept, so I'm going to skip finding that one and just write it down, x equals 0. And then my third one, I'm going to hit second trace, find my 0. I'm going to go ahead and skip 0, 0 because I already know what it is. I'm going to move to the right, and you're like, my cursor disappeared. That's because it's at 1.063 comma negative 16 right now. It's going to keep going down, and then at some point it'll come back up and go way too far, so I'm going to go back. There it is. All right, so it's to the left of that 0. I'm going to hit enter, and now I'm going to toggle to the right, and it's to the right of the 0. I'm going to hit enter, and then enter one more time, And it tells me my third 0 is 4, 0. Or sorry, my third 0 is x equals 4. So my third x-intercept is 4, 0. All right, last one. If you remember from previous notes, this one was, we had to use the quadratic formula. And that means that these answers for my x-intercepts and zeros are going to be messy. I believe it was 2 plus or minus root 3. So whatever that is a decimal, is going to be our answers for our zeros. All right, y equals, clear this out, x squared minus 4x plus 1. Hit graph, or did I hit zoom in? No, I didn't. So hit graph, or you can hit zoom standard. All right, let's start off by finding our y-intercept. It's 0, 1, but once again, you can hit trace, 0, enter, and it tells you it's 0, 1. And now let's find our two zeros, the two places it hits the x-axis. Second trace, option number 2 is 0. I'm to the left of the first one right now, so I'm going to hit enter. And now I'm going to toggle to the right until I'm to the right of it. Hit enter, enter. And my first x-intercept is 0.268, comma 0. Or 0 is x equals 0.268. 3 decimal places when directions are not given. All right, and the second one. So second trace, option number 2 is a 0. I want to be to the left of that 0, which I am already, but I just want to get closer. All right, there we go. And then to the right of that 0. Here we go, hit enter, guess, yes, I should. And I get x equals 3.732. And the ordered pair, 3.732, comma 0 for my other x-intercept. Now, I do believe I remember it from yesterday. I think it was 2 plus or minus root 3. I think, let's see, 2 plus root 3. I could just look it up, but I'm trying to use my memory. There's that 3.732, 2 minus root 3. That's what we got when we used the quadratic formula. Same answers there. Okay, now last part is doing it algebraically. Okay, so this is a review of the previous notes. No calculator, so I'm going to get rid of it. And then I need to find the y-intercept, x-intercepts, and zeros. So I'll start with the y-intercept, plug in 0 for x and see what you get for y. 0 squared plus 0 is 0, so my y-intercept is 0, 0. X-intercepts and zeros set y equal to 0 and solve. This is a quadratic. I cannot square root because there is an x, so I'm going to try to factor it. There is a GCF of x. And now I'm going to set each factor equal to 0 and solve. I get x equals 0 and x equals -1. So those are my zeros, x equals 0 and x equals -1. And my x-intercepts are 0, 0, -1, 0. So I know I'm a math teacher and I can do this pretty quickly, but we have to admit algebraically is faster than using the graphing calculator. All right, last one, and then we're done for today. Y-intercept, plug in 0 for x and see what you get for y. 2 times 0 squared plus 7 times 0 plus 3 is 3. So 0, 3. And then set it equal to 0 to find your x-intercepts and your zeros. Quadratic can't square root. Try to factor. Look for a GCF. There is no GCF. So I know it's 3 terms. A times C is 6, B is 7. Two numbers that multiply to give me 6 and add to give me 7 are 6 and 1. Divide by your lead coefficient, which is 2. The first fraction here is simplifiable. 2 goes into 6 3 times. 2 goes into 2 1 time. So this factors to x plus 3 times 2x plus 1. Set each factor equal to 0 and solve. Oops, I forgot the 2. And I get 2 solutions, x equals -3 and x equals -1/2. Those are my zeros, x equals -3, x equals -1/2. And then my x-intercepts are -3, 0 and -1/2, 0. All right, that's it for today. Go ahead and get started on your homework.